Yeah, I know. I just like saying super deep borehole. Welcome. Throughout history, cultures around the world have imagined mysterious worlds beneath our feet. The ancient Greeks envisioned the underworld ruled by Hades, and the Norse believed in hell, a shadowy realm of the afterlife for those who didn't die heroically in battle. The Maya civilization, on the other hand, sort of had a complex notion called Xibalba. That was the underworld filled with trials and tests for souls. But what happens when mythology meets science? Today we journey into the Kola Superdeep Borehole, humanity's deepest exploration into Earth's hidden realms, revealing incredible life forms, geological mysteries, philosophical reflections. We're going to look into how do we know about the world when we can't observe it directly. We often think we understand the world beneath our feet, but how do we really know what's down there? We can't dig into the core, we can't see through rock. We build entire models of Earth's interior, of life in extreme conditions based on echoes, heat, and hints. The Kola Superdeep Borehole, Earth's deepest man-made point, is not just a scientific marvel, it's a rare window into the unknown. Today we descend into this incredible project and the discoveries that challenge our understanding of science itself. Welcome to Professor Asma's Guide to Unusual Knowledge. So where is this thing? The Kola Superdeep Borehole is basically about the size of a dinner plate, and it's just on the ground and it's been sealed up. It's in Russia's Kola Peninsula near Norway and Finland. It was started by the Soviets in 1970 as part of the Cold War race for scientific prestige, showcasing technological superiority. You know that essentially the space race came out of this Cold War contest. And the super deep borehole was also sort of one of the great leaps forward, if you will, based on political tension between capitalism and communism. So this was continued until 1994, and that's when it was closed due to rising costs, and there were all kinds of technical difficulties and also geopolitical shifts after the Soviet Union collapsed. There is a sense in which the hole is said to go straight down into the earth, but it actually sort of weaves a little bit here and there, depending on how hard the rock was that it was encountering. It would just sort of curve slightly and then recurve. So it's not exactly straight. It's basically an extraordinary depth of 12,262 meters. That's 40,000 feet, or 7.5 miles deep. It basically was drilled continuously for almost 25 years, and this basically showcases major advancements in geology and drilling technology of the time, and it still stands as an incredible sort of technological achievement. The scientists knew it was going to be hot down there, but they radically underestimated how hot. They found that it was 356 degrees Fahrenheit, and that was essentially one of the things that stopped the whole project. It simply got too hot. The drill bits were sort of melting, and it was basically like incredibly difficult to keep going. Cracks would open up and they would lose equipment and they would have to go fishing for it. Also inside some of these cracks and fissures was water, pockets of hydrogen gas, and this suggested a kind of active geological process that was deep beneath the Earth's surface, and it helped us understand just how dynamic it is down there. To my mind, some of the really fun stuff is the biology, because they were finding actually microscopic life forms. They were finding fossilized microscopic life forms that basically were a kind of ancient plankton that were over 2 billion years old. And this stuff was preserved like deep underground. But also they were finding like live microbial communities known as extremophiles. These are organisms that are adapted to survive harsh conditions like really high pressure, super extreme heat, and like minimal nutrients. I think some of us are big fans of the tardigrades or the tardibears, those things that sort of can live almost anywhere. They even survive out in space. They're sort of all over, but they're microscopic. And so scientists were finding stuff like that. These microbes basically survived by consuming minerals and gases like hydrogen and methane. And that basically challenged all kinds of previous beliefs about life's limits. As a philosopher, this whole thing like intrigues me. I mean, for many reasons. One is the idea that, we know more about many parts of space than we do about what's right under our own feet. So the inner core of the planet is really mysterious. There's a really fun episode that Paul Giamatti and I did on our podcast, our Chinwag podcast, about the hollow earth. So if you get a chance, go back and listen to that conversation. Paul and I had a blast. But the hollow earth theory, oftentimes fanciful, bizarre, intrigues me too, because since we know so little about what's under our feet and in the core, or even just in deep, deep caves, you can't help but wonder, like, could there be these other creatures? And sure enough, we're finding them. Could there be larger creatures? Could there be humanoid or even creatures that have some kind of culture or technology living deep in the earth? So all this stuff is unlikely, but super fun to think about. It's the stuff of great science fiction. But also as a philosopher, I'm intrigued by the idea that science can progress by building models of stuff that we can't observe directly. So since the deepest borehole, that human beings have made, this Kola Borehole, is so far away from just breaking through the crust even though it's 7 miles down, it's nowhere. It's just a little scratch on the surface of the earth. How do we know so much about the earth? And this is a philosophy of science problem, which is, how do you have knowledge of that which is unobservable, or at least unobserved to date? And so this is a common thing in the history of science. Like, we have these cases where people postulated the existence of atoms long before we actually saw an atom, long before we had the technology to see an atom. Even the ancients had this idea of an indivisible particle. And then the moderns, like in the 1660s, people were formulating this idea that everything was made up of some kind of atomic structure. And so this idea was basically a model without an observed corroboration. And slowly, what happens is, sometimes in science you get to have a technological breakthrough and actually observe the thing you postulated, like a black hole. People postulated the black hole long before they actually saw it. In fact, you just see the effect of the black hole. But that kind of stuff intrigues me greatly. I think it's one of the most interesting things and the most wonderful things about science, is that it can claw its way to knowledge and truth even when there's a paucity of data. Even gravitational waves are kind of postulated long before anything is observed, and even to this date we don't really understand how gravity interacts with the other laws of nature and even what it is. Space-time continuum and the curvature of space helps us explain some of what we thought of as gravity back in Newton's day, but people kept asking Newton, like, what is gravity? And he famously said, hypotheses non fingo, which means I make no hypothesis, I make no speculation, I just do the math and make the predictions. We know now, with more recent history of science, that Newton did have all kinds of theological ideas about forces in nature, but he kept those to the side. He was doing alchemy, in his house, but he sort of kept that separated from his work in the Royal Society. So in the case of the Earth, scientists build models of Earth's interior, including like the mantle and the core, based on indirect evidence like seismic waves, magnetic fields, and sort of comparisons with meteorites. These models predict phenomena accurately, sometimes confirmed by direct exploration, yet always evolving as new evidence emerges. The seismic waves, basically vibrations, travel through the Earth, and they're generated naturally by earthquakes or artificially by sort of controlled explosions. And then we measure that stuff and create these maps of how the interior looks. The waves that we pass through the Earth basically change speed at sort of distinct boundaries, like where the crust and the mantle are. And this allows us to sort of understand big discontinuities within the Earth. So shadow zones, which are regions where seismic waves don't directly travel, they indicate liquid. And that helps us understand, what parts of the inside of the Earth are more sort of viscous and which parts are solid. And Earth's magnetic fields, which is generated by movements of liquid iron in the outer core, they further confirm theories about the Earth's core structure. Sometimes when you have direct observation, you don't know what you're looking at. So, thinking about geology, I'm always sort of amused that before we had this understanding of plate tectonics, we thought that there was a kind of process of continental drift. Like if you look at, the geology of the planet and it looks like it was once one sort of Pangea supercontinent, and then it broke apart. And when you look at the map, you see these puzzle pieces that fit together, Africa with the Americas and so on. So you can imagine that these things were once together, they broke apart and moved, that somehow the continents pushed their way through the seafloor and ended up in their contemporary positions. But people realized there's no way for that to happen. There's no mechanism for that to happen. So even though you're observing this thing of these jigsaw puzzle pieces, you don't know what the mechanism is to sort of bring about that phenomenon. So plate tectonics was an adjustment of continental drift theory, where they said, okay, there is something drifting and moving, but it's not the continent, it's the plate that the continent is rooted in. So the plate is basically coming out of these dynamic deep sea vents. It's emerging out slowly and buckling against other plates, and this is creating like mountain building. And also, as the plate goes over certain volcanic hotspots, you end up getting things like the Hawaiian Islands, which you can see exactly how the plate spread across it. So that's a really interesting aspect too, in which you've got this wonderful play between observation and theory. And eventually, of course, we confirmed plate tectonics from these different observations and theories. It's also the case that when you get down and you discover these extreme life forms down in the borehole, it's something we can use to try to understand sort of astrobiology. What is life going to be like if we find it on Mars, for example, or outside our own solar system? Over time, the Kola Borehole has inspired some eerie legends and superstitions too. Like one of the famous myths is the well to hell, which claims that researchers lowered microphones into the hole and recorded chilling sounds interpreted as screams of tormented souls deep from within the bowels of hell. Widely debunked, this urban legend continues to capture public imagination, and it highlights how exploration of Earth's depths still fascinates and unsettles us. So the super deep borehole reveals exciting connections between scientific discovery, sort of philosophy of science, and it reminds us that exploration is as much about imagination as it is about rigorous investigation. It's continually reshaping our understanding of life and Earth's deep secrets. On a personal note, I have to say that the super deep borehole also gives me a slight panic attack when I think about it. Ever since I was a kid, I've been fairly claustrophobic, and I have these kind of nightmares and constant fears about being trapped underground, buried alive, and also just in like a really tight space where I can't get out of. So these like YouTube videos of people spelunking and getting sort of stuck as they crawl through these little cave gaps and openings, that makes me very tense and stressed out. So it was with some trepidation that I did this particular episode, but some of our Patreon friends basically suggested this topic and asked me to look into it. And for that, I say thank you. And also, I hope you appreciate that I dug in on this topic. So if you do want to make suggestions about our shows and vote on topics and see other sort of monthly videos that are not available to the public, please go to Patreon and sign up there. And we really appreciate that community. So thanks to all of you who are there. And it's a growing and wonderful group of strange and intellectual folks like, I think this show in general. And finally, not to leave you with a kind of disturbing and panicky thought, but one of the things that also troubles me about the borehole is the same thing that bothers me about the slowly thawing ice in the Arctic. And that is, what would happen if some of these microorganisms, like these microbes, were to get onto the Earth's surface and become a kind of invasive species? Because this happens in evolution all the time. You have these various ecological niches in which animals are sort of thriving and surviving, and then a invasive species arrives, and it turns out to be a very good predator or a pathogen, which wipes out a lot of the local ecological community and then takes it over. You think about certain plants like kudzu, which just wipe out, whole forest regions by choking off the local flora. What would happen if some of these microorganisms get up here and get into human beings, or, other animals, get in the food chain somehow? So that's something we should think about as we're drilling down into these deep holes. Maybe there's a reason that shit should stay down there. Okay, Thanks always for joining us. I'll see you back here next week. And remember, always stay curious.